this unit, which is probability. So we're gonna, which is something you've already done last year. All right. So we're gonna talk about independent and dependent events today. Events are independent, okay, when the outcome of one event does not affect the outcome of the second one. So in other words, if you flip a coin twice, 2 times, does what happened on the first one, heads or tails, affect what's going to happen on the second one?
No.
No. Now you learned last year about theoretical, meaning what's supposed to happen. Like if you flip a coin 100 times, how many times is it supposed to land on heads? 50, right? But we know with experimental, what actually happens, that might not be true. Now, probability over time, meaning the more you do it, the more likely it is to get closer to 1/2. Just like spinning a spinner, rolling a number cube. All right? So it's usually written as a fraction, okay? But you can also write it as a ratio or a percent. What do you usually hear, for those of you who have television, on the weather at some point? What do they use? The probability, the chance that it's going to rain. How do they usually express it? As a fraction?
No.
Ratio?
No.
Percent, right? There's a 20% chance. There's a 30% chance. That's how the probability is expressed in the weather. Okay. With things like rolling a dice, it's usually out of a fraction, right? Because that's more visible because you have 6 opportunities. So the probability of an event and the probability of the, we're going to call it the non-event, or the opposite of an event, always add up to what?
100.
100. 100 what? One or 100%. I knew what you meant. All right, a lot of times you're going to see the probability, this right here, that means probability. So that's the kind of the question they're asking. Okay? So you'll just see the capital letter P, and then in parentheses you'll see like 2 on a number cube, and they just want to know what's the probability of rolling a 2. This is what's going to happen. Or not happen. The event is what's going to happen. Sorry, this or not happen. Okay. So a lot of times you're going to see it written as favorable over unfavorable, not favorable, not happening over not happening. All right. So let's go over some examples. Now, where it gets tricky is when we talk about multiple things happening. I don't know if you guys did that last year or not, when you have the probability of 1 or 2 or more things happening. All right, so in this particular one, it says a bag contains 6 red, 15 green, and 9 blue. So the first thing I would suggest is finding the total. Okay? So the total, in this particular case, would be what? 6 plus 15 plus 9. 30. Right? So 30 total marbles in the bag. All right? So then you're just going to express it in whatever they ask you. The probability, remember I told you that big P means probability, and then in parentheses, it means what they're going to pick out, and that would be green. All right, so the probability of green. How many green ones are there? Over total? Now remember, we always, let's write that down. Always simplify. Okay? So in this particular one, what is 15 over 30 equal? 1/2, good. All right. Probability of blue. How many blue ones are there? 9 over how many?
30.
30. Can we simplify that? 3, right? 3 over 10. How about red? 6 over 30. Can we simplify that?
Yeah.
1/5? Okay. Now, here's where it gets a little more tricky, and that's really kind of the best way to describe it. Please read. It says the probability of not green. So what would you have to do? John? Say the answer?
Wouldn't it be a 1/2 again?
Why? You're right. Yeah, the other half. So if you know the probability of green is 1/2, the probability of not green would be 1/2. Now, it works out nice and neat that way, but what we want to do is count up again. So 15 out of 30, 15 would be not green. Easy. Right. So like John said, if the probability of green is 1/2, the probability of not green, okay, but you would add up all the ones that are not green. How about not blue? 7 out of 10, right? So you got what? So we got 21 out of 30, right? Because we got red in there. 21. So it would be 7/10, and then not red,
4/5.
which would be what? 24 over 30? Right. All right. Green or red. Now, here's when you see the word or, you have to add green plus red. So how many green are there? And red? So it'd be 21 out of 30, right? Which is what? Which is what? 7/10. But John, just like you figured out if this one was, if not green, had to be 1/2 because green is 1/2, green plus red, which one should it be the same as?
Wait, why is green or? Oh, we have to add the green or red. So we have to add them.
Not blue, right? Okay. So you can do it that way. Most of them won't be as straightforward. Green, red, or blue?
30 out of 30.
30 out of 30, which would be what? 100% chance you will draw one of those. 1. Remember, 1 is the same as 100%. And then how about yellow? 0 probably. All right. To find the probability of 2 or more events, you have to find the blank of their individual properties. What do you have to find? The fraction,
Nobody's laughing.
the chance, or the probability of their individual ones. So here we have 4 black shirts, 6 red. Bottom of your closet
That.
should be folded up away in your hanging. You'll pull out a shirt without looking, replace it. Here's the key right here. Everybody underline this, please. Replace it. That means you put it back. Okay? Now, what's the probability of pulling out a black one?
With 4 times.
4 out of 10.
2/5.
Then you put it back. Here's the key. Pull out another one.
So 8 cents.
Multiply. Okay, you're going to multiply. So 4 times 4 is what? 16 over what? 100, and then we can simplify that to what? 4/25. So it's 4 out of 25. The more they ask you to do, the less likely it is to happen. Does that make sense? The more they ask you for, the less likely, unless it says or. Or we add and we multiply. And multiply. Okay? So, or we add and we. Yes, Megan.
What does that say?
The events. You multiply the events together. So then the same would happen for a red and a red. Red would be what? 6 out of times 6 out of 36 over 100. Remember our fraction. It's a lot easier to simplify first, right? So that would be what? 9/25. It's easier to simplify first. Red and black. So red would be what? 6 out of 10. Black would be 4 out of 10. That's going to give us what? 24 out of 100. Then we simplify that. 6/25. Okay? All right, any questions? All right, events are blank when the outcome of one event does affect the outcome. They're dependent. They depend on each other. Okay? Choosing 2 marbles but not putting it back. So in other words, the big box of cubes back there, all the different colors, if I don't put it back, it affects how, let's say I say pull a yellow one. If I don't put it back, it affects how many yellow are left and how many total are left, right? So this, right? Probability of A and B. All right, you ready? So what's the problem? All right, there are 2 yellow, 5 orange, and 3 purple. Don picks a purple marble and keeps it. So let's add up. What's the total? Equals 10. Got it? Right? All right, so yellow is what? 2 out of 10. And then what? then purple. Keeps it though. Remember, he doesn't put it back. So there are still 3 purple, but how many total? 9, right? So we're going to get 6 over 90. Okay? And then what? Simplify goes 6 goes into 6 once, 6 goes into 90, 15. 6 goes into 9. 3 left over is 30. All right. Everybody see that? How about orange? And then yellow. Remember, there's still 2 yellow, but there's only 9 of those left. So we get 10 over what? Which equals 1/9. Ooh, yellow then yellow. Now here's where it's going to affect the draw. So we got yellow is 2. We got out of 10. Remember, there's only 1 yellow left. So we're going to get 2 over 90, which makes 1 over 45. All right, purple. 3 out of 10, then orange. 5 out of 9. It's going to give me 15 over 90. And Gabe, we already learned that 15 goes into 15 once, 15 goes into there. 6, right? The other thing you have to do is determine whether it's independent or dependent. What's another subject that you've learned this in? Not Math 7, but science, right? Do it all the time in science. Sam flips a coin and it lands on heads. He flips a second coin. Does what happens the second time, is that independent or dependent of what happened the first time? Independent. Can I just write I? Thank you. How about a guest at a party takes a sandwich off a tray and eats it? Hopefully doesn't. Then second guest picks a sandwich off the tray. Dependent, right? Because there's not as many sandwiches.
But how does that affect the next?
Well, all right. That's a good question. Let's say they're like 3 turkeys, 4 salamis,
So we'll not specify.
5 tuna, 2 peanut butter and jelly.
Can we specify that?
Sure. So if he picks one off and eats it, right? There's not as many to choose from, so it does affect.
Okay.
You select a king from a deck of cards and do not replace it. That means you don't put it back. Are they the same number of cards?
No.
No. So that does depend on, right? Whether you do this or not. This makes it dependent. If you put it back, it would make it independent. How about rolling a dice and flipping a coin?
Independent.
Independent, right? Right. Pretty easy, yeah? All stuff you've had last year.
It's like,